think Riley got one.
Okay, so
Yeah. Like over 300 for 500.
okay, so kindness week this week, of course, today, PJ Day, but it's also during homeroom next period. You will write thank you letters to frontline workers at Parker Center. So that's going to be really good. So when you go to homeroom, it'll just be, you can write a quick notes to somebody, just in general, thanking them for all of their work, kind of putting themselves at risk over the last year. Because we are about a week away from the 1-year anniversary of us shutting the school down. So crazy, it seems like a long, long time ago. But I think we're over the hump and headed in the right direction. So we definitely want to thank the people that have been working really hard to get us to this point. What I wanted to do today, as much as I like love teaching you new things, I think it's really important that we pause for a second and actually try this stuff out on your own. I think you need to actually work through the mechanics of doing these limits and finding the derivative with different kinds of polynomials. And that's all we're doing right now, is just kind of working through simpler kind of polynomials. And so I included something at the bottom of today's announcement. Homework 2.1. So we'll just do it in class. It's called homework, but we're going to do it right now. Finding the derivative of some or all of these. Now, this is not in your guided notes. They didn't have quite as much practice as I thought that would be useful. And so at goodness knows what time last night, I had the epiphany. I was like, you know what? We need to stop. We need to slow down. As much as I want to keep going and get to radicals and rationals and sine and cosine, I think it's important that we make sure that we can do this right, especially because now I can give you some feedback on notation, on setups. We can talk a little bit about how to do it really well and make sure it all looks good. So click on that homework 2.1 if you're at home. In class, I will just post it so it's big enough so you can just kind of work through it. You don't have to do all of them, but I do want you to do at least some of each of these kind of 3 types of functions: linear one, quadratic, and a cubic. Okay, so for the linear one, you can pick one or the other, or you can do both. You can do as much as you want. For quadratic, pick any of the 2, whichever 2 you'd like. If you want to do the third one, great. And again, same thing for the cubic. Pick any 2, or you can do more if you want. And what I want us to get to the points today, I want you to feel like, okay, I really have a good handle on our style of working through these limits. Evaluate, expand, simplify, factor, divide, and plug in. Okay? And the thing that I thought was helpful, and so I'm going to move the camera over here in just a second. I did the expansions for x plus h squared and x plus h cubed, so you have those sorts. Okay? I think that those would be really helpful to write down at the top of this page so you can hold on to them for the future. There's nothing to the 4th power, but we will potentially get to that. But usually that's about as far as we need to go. That's, if you can do squares and cubes, you can do it. So, and just today, let's just practice. And once you get it done, you're done. I'm happy with that. Okay. We will pick up radicals and rationals tomorrow and kind of see what happens. But we're going to know how to do those limits. We'll just have x's and h's. And that's it. We'll just practice. And I'm going to make my way around in class and kind of look at how you're doing and give you some advice on what you can do a little bit better, or tell you what you're doing great. The other thing that I want to do for the folks at home is I want to give you guys some feedback tonight once you submit this, which can be a little bit harder to do through a computer. I can't point at your work, so maybe we'll even find some time tomorrow to talk. But with the linear ones, we know what answers we're going to get. The slope of the line is the derivative, right? That's exactly what it is, the slope of the tangent line. And so I know what the derivative of number 1 is going to be. And having that kind of in mind, knowing that f prime of x is going to be 3, knowing that ahead of time, once you get 3 as an answer, yay, I know I did it right. How do you think I should write the derivative of the second one? Should I put f prime of x again? G prime. Okay, and that's going to be -1/2. Absolutely guaranteed. Okay. And then, so same thing for like number 1 with the quadratics. Yeah, it's not F or G, it's H. Okay, so H prime of X. And then this will be the last thing I say, and then I'll just kind of let you work. What about this one? Number 2 for the quadratics. What do you think might be a good way to write the derivative of that if it's not written as a function? F prime, G prime, H prime of X, those are all nice when they're functions. And this is a function, it's not written as a name of a function. What do you think we might write instead? Y prime, sure, absolutely. Okay, so once you get there, call it Y prime. And I'm going to start putting up these derivatives so you know that you're getting them right. Because I already know the shortcut, so I can figure out the derivative right away just by looking at it. But I will give you a chance to at least get those, the first linear one under your belt. And I'll just kind of make my way around and help you out as much as I can. And if you guys at home have any questions, or if you can't see anything here, let me do this part first. I want to scoot you. So you can see the expansions of the quadratic and the cubic for x plus h's. In case you need those, come on, you get up there. Oh, of course, I'm in the glare. You son of a gun. It's like the only one is the cubic one. Let me try that. At least you can see the cubic one now. The squared one, you probably know, x squared plus 2x h plus h squared. There's the cubic one. Let me know if you can't read it. And then I'll bring you back and I'll point you at the actual one. Now, so I keep saying, hey, I'm gonna stop talking. Yeah, that'll be the day. Make sure the first thing you write down whenever you start a derivative is the derivative, right? F prime of x equals. Okay, cool. Then I'll get into my limit and I'll kind of go from there. Okay. But don't just start by saying the limit is equal to 0. Okay, say F prime of x, G prime of x equals, or Y prime. Whatever. Okay. Look back at the definition in case you need it. And minimum of 5 problems in 45 minutes. That's 9 minutes per problem. That should be fine. But if you do all 8, that's only like 5.5 minutes. So don't feel like you have to get all the way through. Especially, this one looks fun, number 3. Relax, work on master this stuff. And then we'll believe. Proven to improve your mathematical brain development. Yeah. Literally scientifically proven to make your brain work better, especially when doing mathematics. I remember my pre-calc teacher in high school said that every day. And then I got a 5 on the calculator. So I don't know. Can't argue with the results. All right, I'm gonna start putting some answers down so you can see if you're getting them right once you get to the quadratic and the cubic. And then I'll come. And by like early next week, this is as fast as you'll be able to do them all. So, no, not that. Yeah, you take it on here, on there. Arrows. Things like that because it's equal. You shouldn't, not necessarily. Limit of 3 is equal to 0 equals just 3. If your last line will have a limit. And I love that line. The limit of this constant is equal to 0 equals, and then just it's not that, it's the limit of just that as h goes to 0. That limit right there. The limit of h goes to 0 of like f of x plus h minus f of x all over h. So if you just say it's the limit of your function, there's no h in there for me to actually plug anything in, and it's going to get the same thing back. You want to actually like write it out like this. Or if you want, you can jump right to like the step where you actually do it. Like if I'm looking at, let's say like the quadratic, number 1, x plus h squared plus 2, x plus h minus 5 minus x squared plus 2x minus 5 all over h. That's what that first line does. That makes sense? Word of operation says let's do exponents before we multiply anything in. So you'll have -2 times all that. Now you can do that all in one shot. Like if you have this either stored up here, like written somewhere separately. Oh, you just want me to do -2 times that? Okay, -2x squared minus 4x. Like you can just like multiply that constant in. So you're not doing like 2 lines of expansion. Because if I want to take the limit of h equals to 0 and I don't have it, I'm only taking the limit of like 2x. Here's a really good way to think about that. What's 3 being multiplied through right now? Just the x, right? If I wanted to go through everything, I better put parentheses around that. That's kind of like doing this. What am I taking the limit of? Just the x right now. Now it's the limit of x. Yeah. Other than that, it looks really good. So f prime of x equals f prime of x equals. No equal sign between your limit and what you're taking the limit of. It's the limit of something. It's kind of like a function, like I'm going to take the limit equals. And I like how close this fraction is to your limit. I less like how much space there is here. I feel like they're disconnected and they're really like limit of this. Like, I'm gonna have to stay connected. So it'd be pretty cool. But I like. Don't plug in 0 until you factored out the h and divided it away. Because that line where you actually dropped in 0, you have dividing by 0. So I have to make sure I divide away the h before the 0 goes. Right. And that looks great. But you multiply 3x times 0, that becomes a 0, and that's it. So it's just 3x. The only thing that I can't do with like number 2 from the quadratics and number 1 from the cubics is I can't write it like this with function notation. I'll just jump right down to here. Like I'll just go, okay, y prime equals, and then jump in and just do it. I can't call it f of x plus h if it's not f of x, right? And the thing that you want to watch out for with like, even just with number 2, and I don't know if I caught this, but like the limit as h approaches 0 of f of x plus h, well, this is not f of x, this is g of x. So if you're writing it, it's got to be the limit as h approaches 0 of g of x plus h minus g of x all over h, right? Make sure you're bringing that notation, that name of that function with you. Right like that. I really can't write f of x plus h if I don't call it f of x. If it's just y, then I'll just kind of skip down to just jumping in. There we go. Yep. Yep. Let's call it y. Yeah, so you can say like as soon as you're going to try to do something, tell us what that is from the beginning. I'm going to find the derivative and here's how I'm going to do it. So I can do it right now. So that's kind of like. And a lot of times they will each of x if we're going to have an each. Maybe here's going to be a little misleading for the that fraction bar all the way across. All the way across. There. This is kind of something that I was saying to her before. Here's why the parentheses are necessary. What's the 3 being multiplied into right now? Just the x. Now it's everything. And that's the difference. I want to take the limit of all that stuff, not just the first. That's what all So you went from here to here, so you didn't factor out the h and then divide it. You said it's everywhere. I'm just going to divide it away. Are you good? That equals this. Of x is equal to that. You're connecting all of these in one long inequality. There's your function. Okay, now next line of work. Here's the derivative of that function. That's totally different. Don't connect them with equal signs. There are only two functions that I can go off the top of my head. There's a function of derivative. A line like 0. There's 0. So you be careful. There you go. That works. Yeah, you don't have to. So I don't know, like from here to here, if you're doing anything critically important because it's 1 half, the negative 1 half times 8. Now it's 8 times negative, the same thing. So if you do a monomial, like get rid of h right away. I don't think you need to write that second line and just fast it out. It doesn't mean one time. Here. So when you pull out the h from this 3, you put it right there, that h is going out. That h should be this one. So that h is this one, however you want to write it. And I don't know that you necessarily have to say, like if you're here, like is it really critical to pull the h in front of the 3 instead of having it behind? This and this are the same. I'm good. Like just get it right there. Let's call this 3 and then 3. I think we're good to see ourselves one step forward. It's not wrong. This is we're not making a problem.
Yeah.
So I want to get closer to the door. Right? You know, I'm not really getting. The same thing that I was saying right here. What is the 3 multiplying into right now? Okay. Now what was the 3 multiplying into? Right? And so if I said this, what am I taking the limit of? Really just x. Now I'm taking the limit of all of x, whatever that is. So that looks good. Yeah. Okay, so the thing about the cubic ones is it doesn't use the same x squared 2x8 h squared. It's a different expansion. Yeah, so I think having kind of like both of these written down somewhere so you know which one to use when. So when you're expanding the cubic versus expanding the quadratic, you're going to get a totally different setup. So I think maybe backtrack yourself. Get rid of that numerator right there. And use the expansion x plus h cubed, x cubed plus 3x squared h plus 3x. And use that one up top. And then you'll subtract the x cubed and it should do it. Yep. I love the shortcut. You're gonna love it. It's gonna be like Monday or Tuesday. We'll be able to figure that out. So we still have like 20 minutes. We got lots of time. Hopefully you're kind of making your way through the quadratics at this point, maybe getting into the cubics. That'd be cool. And you've seen a lot of different variations of the kind of ways they're going to present it. They're going to call it a function as f of x, and that's probably the most common one. They'll change the name, call it g or h. They try to avoid using h of x because we already have an h in the limit, and those would be kind of confusing because they do two different things. So I will try to avoid h as much as I can, but it does come up, so I just wanted to show it to you. The y equals with the y prime. Say the derivative of y, that's what we'll do. And then, obviously that last cubic is a monster. That's like a turn your paper sideways kind of problem because it's going to take you so long to expand that out. But there is a reason why I picked that one. Let me just check the chat here. I heard a bleep. Quadratic number 2. Okay, so for quadratic number 2, is the expansion of this? Like I'll just kind of isolate that part. Is that the part, Delaney, that's trickier?
So I have that whole thing and I think it's right, but the one part I'm not getting, I'm at 6xh plus 3h squared. Is that right?
You must be missing a minus h somewhere because
I have that minus h at the end, but then I factored it out.
So, but if you are factoring out h from negative h, you have a negative 1 closer.
Oh, okay. Thank you.
Last one, that cubic, that's a bear for sure. But it's a good one. And there's actually a pretty specific reason why I chose the notation that I did. S of t. Is anybody in physics right now? Does Cunningham use S of t for anything? Or does he instead use distance over time? Have you seen anything about like distance, displacement, stuff like that? So D is good for distance. So like, I stand over here and I'm going to walk toward the door, but I'm going to do it all weird in like 3 dimensions. And I'm going to jump. Like the distance, like the tip of my moccasin is traveling right now. That's D of t. S of t is displacement. There is no third dimension. It's just up and down. It's called the position function. And we'll get to it. We'll actually get to talking about this. That's the position function. And I just made one up that is not the position of anything we're going to be studying, and nothing that we have to worry about is going to be cubic. But it's a position of time, so that's why I chose t. So when you set this up, that is not going to be f of x plus h. That's going to be s of t plus h minus s of t all over h. You have to use whatever the variable is. And as nice as x is, t makes a lot more sense for tracking the movement of something over time. Okay. Now, ys, when we're talking about distance or displacement, the German word Strecke, which means distance. But you can say it just like that. Strecke. ST comes out like Strecke. Yeah, so that's why I choose S. Leibniz, Gottfried Leibniz, German mathematician. A lot of Germans have big roles in mathematics, especially in like the 18th century. A lot of really smart people in Europe were kind of traveling along and meeting other people and sharing ideas and stuff. The Silk Road of mathematics. So that's like what S. I don't love S. It kind of looks like a 5, but it will come up. But like talking about position, velocity, acceleration, stuff like that, you're going to see huge connections between calculus and physics. They are the same. Physics is calculus. It is the calculus of motion. Calculus of force, gravity, all that stuff. We're going to get all of that going on for sure. There are all those derivatives. See how you do. When you're done, you're done. Put it up on Canvas. There's a homework 2.1, and we're good. But I thought this would be really helpful. Actually, like getting our hands dirty and trying these out, and me getting a chance to kind of peek over your shoulder and help make things look really good rather than just very. To do at least 5, but any more than that is always good. Number 3 at the end there, that's if you want, but it can be done, of course. Anything can be done. Polynomials only for now. We'll see with radicals and rationals what we'll do tomorrow. And I said this yesterday to Court B when they were in class. But Miss Hogan will be here for my observation during our class tomorrow. But nothing changes. She could be here every day and still teach the same way. Which I think should be what any teacher would do. It doesn't matter who's in the room, you do your best. So I won't affect you guys because you'll just be at home. But she'll be floating around. She's super nice. And she's actually a former math teacher. So she's excited to come to calculus. We get to do radical limits and rational limits.
Where does the minus 4 from?
Oh, when you plug in exponent right here, that x, you also have to do here. So it's minus 4.
Okay.
You'll get a negative 4x, but you also get a negative 4h.
Okay.
Yeah. So wherever you see an x, in goes an x. If things aren't going away the way you want. So one thing to be careful of is the other variable t.
Yeah.
Don't change it because you've written it so many times, but it would be t.
Okay.
Maybe that's why, because you did write it with t's over here and you wrote it with x's over here.
Yeah.
So let's do make the change. Change all of your x's to t's and then watch it all. Well, lots of things anyway. Maybe at least 4 terms. Yeah. And that's why I put that one in there, because we're not used to seeing independent variables in anything but x, but t is a very, very common one. Especially in calculus, because things change. And again, when you've had your fill, you are good. If you're getting them all done, awesome. If you're getting at least those 5 done, right, 1 from the first and then 2 from each of the seconds, that's great. Straga. Actually, I spent 3 months in Germany after high school. I took a year off, took a gap year. A story for another day, perhaps, but I was pretty conversationally fluent after those 3 months. Like I flew to Germany having had 2 weeks at a community college of like introductory German before I got over there. Which was basically like, where's the bathroom and may I have a beer, please? That was about it. And it's not really that hard because the word in German for beer is beer. It's just spelled with an I-E instead of E. So that was easy. But immersive language learning experiences are by far the best way to learn language. And especially when you like go to Germany as an American, but you look like this, blonde hair, blue eyes, people just walk up to me and start shouting German at me. I'm like, whoa, 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 from New York, I'm from New York, slow down, slow down, slow down. But English is a second language to German. They start taking English in 1st grade, and they take it all throughout school. They have 13 years of high school, or 13 years of school. They actually graduated like 18, 19 before they go to university. They don't call it college, they call it university. But they're all like every person basically, unless they choose not to be, is fluent in German and English. So it made it a lot easier. It's like, oh, okay, I'll just talk to you like an American. But that was an awesome trip.
Did you like taking me back there?
I did. I needed to. I was young for my grade. I wasn't really ready for college yet. I turned 17 senior year. Turned 17 senior year. So for a lot of reasons, I wasn't ready to go. The schools that I got into, I couldn't afford. My dad was a teacher. My mom wasn't working. She's fine. She got sick, but she just couldn't work anymore. She's fine. So we were living on one teacher's salary and disability. So I couldn't afford to go where I had gotten into. Despite like I had athletic and academic scholarships, but I just didn't have any. I didn't have any rides anywhere, full rides. And so instead of like going to a school that I couldn't afford, we decided to take a gap. And so growing up, both my parents were working. My dad was a teacher, and well, he was in construction, and he also did some television work. He was a voiceover actor. He's got this really deep, like announcer voice. So he was good for. He did a lot of commercials. But because they were both working, and my brother was older, like my brother is 7.5 years older than me. He was in school when I needed to be taken care of as a young kid, and so we actually had a German au pair stay with us when I was young, like a young lady in like her like late teens, early 20s, came to live with us, kind of like be my my caretaker while my parents were at work. And so when I graduated high school, I was like looking for something to do that I might never have a chance to do again, and that was traveling for sure. And so we actually reached out to her and said, hey, we graduated high school, he's gonna take a year off. We'd like to kind of return the favor. Like, could he come out to Germany and be your American au pair? Like, could he be like that person for your kids? Because she had 2 little kids. The same au pair who was like 20 years old is now like in her like late 30s, early 40s with a 5-year-old son and a 7-year-old daughter or whatever. She was like, yeah, I would love that, but we live in this tiny little apartment. We really just don't have a space for a 5th person between me and my husband and my 2 kids. But my brother and his family have a 9-year-old daughter and a 3-year-old son, and they have some space. Would you want to live with them? So I said yes. And so I flew. So I graduated high school, and that fall I flew to Europe by myself. I actually spent a week in London first. I had a friend that I graduated high school with that was doing a semester abroad in London. So I stayed on her dorm room floor in London for a week. And then flew to Stuttgart, Germany, and met my host family and stayed there for 3 months. So it's kind of like the older brother in the family. Like I walked the younger kid to kindergarten, and that's actually a German word, kindergarten. Kinder means child, garden means garden, a place to grow children. Kindergarten. Chopped wood, mowed the lawn, helped cook dinner, and all that kind of fun stuff. But I got to travel around Germany. We went to Oktoberfest. We went to a soccer game at Olympia Stadium in Munich that had 80,000 people in it. And when I was in high school, my graduating class that year, my senior year, we had a German exchange student from Berlin. So then I went to Berlin and met her and hung out with her and her boyfriend for like 3 days. It was awesome. Traveled around up there, went to the Swiss Alps. So cool. We do have a couple minutes. Can I tell you a story? Yeah. Okay. So backtrack to London. Okay. So I am 17 in London with a very close friend of mine from high school, super, super nice. She's actually the lead singer of a band. I don't know if you like kind of like folksy, bluegrass kind of southern stuff. But check them out if that's the kind of thing you're into. They're called the Honeycutters. But I think the full name is actually Amanda Ann Plax and the Honeycutters, because Amanda's a friend of mine. Super talented, super nice. So stay with her. Super weird side story too. My best friend that I didn't go to high school with was this girl named Chelsea. And I ran into her in the dorm in London. Like, just ran into her. What the heck are you doing here? She's like, oh, I'm visiting your friend. So weird. Anyway, so one of those nights in London, it was like a Thursday or Friday night, and everybody's kind of done what they were doing. And they were like, oh, there's this new band that I heard about. They're playing in this pub kind of down the street. You guys want to go? And so I was staying in a girls' dorm room, and so these girls were like, oh, the drummer is so gorgeous, the lead singer is so hot, we gotta go check him out, come on. And I'm like, okay, cool, we'll whatever, we'll go check him out. So we go to this little pub, and it's this tiny little place, and there's like nobody there. I was kind of surprised, because it was like a Thursday, and I was like, Thursday, London, September, it's really nice out. Surprised more people went out, but whatever. So we hung out. Band was pretty cool. They're just kind of poppy, but really talented. Guys like in their 20s, I think, and but literally like 10 people in the bar, and the band was half of those people. And so after the show, we just kind of all hung out together. Had a couple drinks. They gave us signed copies of their CDs and like signed the ticket stub or whatever, like this little piece of paper, and like that was that. Like never saw them again, right? And during that trip, I like kept a diary. I wanted to like keep track of what I had done. And so like I stuck that ticket stub in my diary. Had the CD for a while. I think I lost it in a move once I actually got to college, but went back and actually found that diary. And like stories of like my trip in London and in Germany and all the fun stuff that I did. But like it was like the third day that I was there, and I really hadn't had any jet lag yet, which was pretty cool. When I got to Germany, I got the jet lag. But I like turned to that ticket stub just for nostalgia. I was like, oh, I remember that band. I remember going to that. They're pretty cool. They're pretty good. And I look at the ticket stub, and this band that we saw in this tiny little bar, hung out with, had drinks after, signed copies of whatever. The band, Maroon 5.
What?
Maroon 5. Mm-hmm. They were just getting started. 2003 was the year. 2003, I hung out with Maroon 5.
That's pretty cool.
So cool. And so I tell that story whenever it kind of comes up naturally. And I remember I was telling this story to my pre-calc class last year. And I had a kid in it that I also had in Algebra 2 the year before. So I was starting to get into the story, and I set it up. Maroon 5, you never gonna know, right? And so like I'm starting to tell the story about Germany, and she goes, tell the Maroon 5 story. I'm like, and I'm like, okay, great. I'll tell you the Maroon 5 story. I wonder what the punchline is going to be. But really, really cool, and it's just a really fun memory. So I loved taking a gap year for sure. It was one of the coolest experiences. I would have ever had the time to do that. Right? Went to college, graduated.